Hello everyone, welcome back to the DSA series. Today we are going to be implementing a queue data structure in C. Now if you guys don't know what is a queue, I made a video titled What is a queue, which will pop up as a card on the screen, and also I'll leave it as a link below in the description. In the previous episodes, I also did implementation on implementing a stack in C. So you guys can check that out. I'll leave it as a link in the description, and also it will pop up on the screen as well. So if you guys don't know, a queue data structure can be implemented using an array, and it can also be implemented using a linked list. Today, however, we're going to be implementing the queue data structure using an array. And in the next episode, we're going to be implementing it using a linked list. So without further ado, let's start implementing our queue data structure using an array. So let's just do vim queue.c, and let's start writing our code. So we'll include our standard input-output library.h. We'll also include our stdlib.h header file. And let's start defining our queue data structure. So we'll do a type def struct queue, and it will be of the type queue_t. Now, since we're using an array, guys, we'll have a int pointer array, and then we'll need to have a size t, which will be the size of our queue. Now, guys, we'll create a function to initialize our queue structure. So let's do that. So we'll do a void queue_init, which will accept a queue_t pointer queue. And it will essentially set our queue array equal to null and our queue size equal to 0. Now guys, let's think about the basic operations of a queue. So a queue has three basic operations: enqueue, dequeue, and peek. So enqueue essentially adds a value to the front of our queue, and dequeue essentially removes a value from the front of our queue, while peek just peeks at the value at the front of our queue. So you guys can think of a queue as a first in, first out data structure, because the first value that goes in will be the first value that comes out. You guys can also think of a queue as a line of people at an airport, where the first person that is in the line will be the first person that gets served. And they will also be the first one that leaves the line as well. So let's start implementing our first operation. So we'll implement our enqueue operation. So let's do a void queue_enqueue operation. So it will accept a queue_t pointer queue. And it will also accept a int value, which will be the value that we want to add. Now, here's the thing about a queue, guys. The last item within a queue is known as the rear, while the item at the front is known as the front, right? So that's pretty straightforward. Now, in order to add a value to our queue, guys, we're gonna need to allocate some memory on the heap. So we're gonna define an int pointer. Let's just call it new array. and it will essentially do a realloc queue array. So it will reallocate memory for our array, and it will be our queue size plus 1. And then we'll multiply that by the size of a integer. So we'll do times size of int, and then we'll essentially, we need to ensure that our new array that we return, that realloc returns, is not null, because we don't want to cause any crashes. So we'll check if not new array, then we'll just return. Otherwise, we'll just set our new array at queue size, which will be our index, equal to our value. And then we need to also remember to increase the size of our queue. So we'll do a queue size plus plus at the end of here, and that is our enqueue operation. Now let's implement our dequeue operation, guys. So our dequeue operation will essentially remove an item from the front of the queue, or essentially remove the first person at the front of the line. So we'll define let's make it return a boolean. So let's make it a bool queue underscore dequeue function, and it will accept a queue underscore t pointer queue, and it will also accept a int pointer value, which will be the value that we removed from the queue. So since we're using the bool data type, we'll need to include our standard bool.h header file. So first, we'll need to check if our queue is empty. So we'll say if not queue array, then we will just return false, which means our queue is empty. Otherwise, at the end, we'll just return true. Now, in order to dequeue or remove an item from the front of our queue, we'll need to essentially get the item at the front, or the value at the front of our queue. So notice, guys, our enqueue, we're essentially just appending a value in our queue. Now, here's what I forgot to do. I forgot to set the queue array to point to the new array pointer. So that will solve any memory allocation issues, So now we can focus on our dequeue operation. So all we need to do, guys, is essentially dereference our value, and then we set our queue array at index 0. And then that will be the value that will dequeue. So then we'll essentially need to decrease our queue size as well now. But first, we'll need to shift the value at the front of our queue to the end of our queue. Since this is an array, we can directly remove that value. So here's what we're gonna do. We're gonna start from our first index. So we're gonna create a loop. So we're gonna say for size ti is equal to 0, is less than our queue size minus 1, I plus plus, and then we're essentially gonna get the current value, right? So we're gonna say int current is equal to Q array at index I. Now that current, let's just call it current value, and then we'll set it equal to our Q array at index I. Now we'll overwrite our Q current index, which is our Q array at index I, to point to the next index. So it will be equal to Q array at index I plus 1. And then we'll set our Q array at index I plus 1 to be equal to our current value that we saved up here. So now that we have done that, it will essentially shift our value at the front of our queue to the end of the queue, and then we'll deallocate memory now. So now we can just say we can essentially just decrement the size of our queue. So we can do queue size minus minus, and then we can say Q array is equal to realloc Q array Q size times the size of an integer. Now here's the thing, guys. Realloc could return a invalid pointer if the size becomes 0. So above here, we'll need to check if our Q, if not Q size, meaning if our Q size is equal to 0, then we will essentially free our Q array, and then we will call our QInit function, which will uninitialize everything. So we'll just call QInit, and then we'll pass in our Q pointer, and then we can just return from our function. We can just return true right there. So now, guys, down here we can just deallocate memory. Right, so we set our Q array equals to realloc Q array Q size times the size of a int, which is the size right here that we decreased, right? And that will be our dequeue function. So let's test out our queue now, guys. So let's do a void main, and then we'll create our queue. So we'll have a queue underscore tq equals to, so we'll null terminate it, and then we'll do a queue underscore, push, enqueue, and then we'll pass in a pointer to our queue, and then we'll push a value of 1, then we'll push or enqueue a value of 2, then we'll enqueue a value of 3, and then we will enqueue a value of 4, and then we'll try to dequeue a value now, guys. So we'll just do a if q underscore dequeue, then we'll pass in a pointer to our queue, and then we'll pass in a pointer to a dequeued value. Let's define it int up here. Let's call it dequeued value. We'll initialize it to 0, and then inside of here now we'll just do a printf dequeued value modulus d new line dequeued value. Now here's the thing about this, guys. So notice we're allocating memory on the heap using realloc. So therefore we'll need to ensure that we free memory. So let's create a function to destroy all memory used by our queue. So we'll create a void q underscore destroy, which will accept a q underscore t point q, and then it will essentially free our q array, and then it will call our q init function, which will null terminate each one of our members within our queue. So then at the end of here, we'll need to ensure that we call our q destroy function so that all our memory gets freed. This should be a pointer. So now let's test out our queue now, guys. So we'll do gcc q.c-oq, and let's execute our queue now. And you can see our dequeued value is 1. And that's because the front of our queue is essentially 1, because 1 was the first thing that we inserted within our queue. Now let's implement another operation, guys, so that we can actually print out our queue. So let's do a void q underscore print q, and it will accept a q underscore tq, and it will essentially print out each values within our queue. So we'll do a printf q values are colon new line, and then we'll essentially iterate through our array and print each values within our queue. So we'll say for size ti equals to 0 is less than our q dot size I plus plus. Then we'll do a printf modulus d new line q array at index I. Now let's make it print out something whenever our queue is empty. So we'll do a check up here. We'll say if not q array dot array, meaning if our queue is empty, then we will essentially do a printf q is empty new line, and then we'll just return from our function. Well, this should be q dot array. So now let's test out our q underscore print function. So if we do a q underscore print q up here, now let's recompile our code and then execute it. You can see the q values are 1, 2, 3, and then 4. Then the dequeued value is now 1. Now let's wrap this in a loop to get a better understanding of how this is working. So let's save the old size of our queue up here. So we'll have a size t. Let's just call it old size, and we'll initialize it equal to our queue dot size. And then we'll say for size ti equals to 0 is less than our old size I plus plus, and then we'll just wrap these in our loop. And then let's recompile our code and let's see what happens. So you guys can see it said our queue values are 1, 2, 3, then 4. Then it dequeued the value 1, meaning it removed it from the front of the queue. So then our queue values now become 2, 3, and then 4. Then it dequeued the value 2 at the front of the queue, and then the queue values now become 3 and 4, and then it dequeued the value 3, then the queue values now become 4, and then it dequeued the value 4. Now let's actually let it print out that the queue is empty, so we need to do it at the end right here. So q underscore print q. And then now you guys can see it will say it dequeued the value 4, and then the queue is empty. Now let's implement one last operation, which will be our peek operation. So we'll make it a bool q underscore peek q underscore t point, and it will accept a q underscore tq, and it will accept a int pointer value, which will be our peeked value. And then So first, we'll need to ensure that our queue is not empty. So we'll say if not queue dot array, then we will just return false. And then at the end right here, we can just return true. So in order to get our peaked value, we'll need to dereference our value that we pass in as a parameter. And we'll set it equal to our queue array at index position 0, which will be the value at the front of our queue. And then that is our peak operation. So let's test out our peak operation now, guys. So we'll do a printf modulus d up here. We'll say the peaked value is, and then we'll print out the peaked value. So let's do a check up here. We'll say if q underscore peak q ampersand peaked value, then we will do a printf the peaked value is peaked value. Now let's define a peaked value up here. Let's move this dequeued value up here first. And we will define our peaked value. We'll initialize it to 0. And then let's remember to put the new line right there. So let's recompile our code now, guys. Alright, so we have an error at line 50. And that's because this should be q.array index 0. So now we can recompile our code and then we can execute it. And you guys can see it said the peak value is 1. Then the queue values are 1, 2, 3, 4. Notice 1 is at the front of the queue. Then it dequeued the value 1, so the peaked value now becomes 2. Then the queue values now become 2, then 3, then 4. Then it dequeued the value 2. Then the peak value now becomes 3. Then the values now become 3 and 4. Then the dequeued values become 3. Then the peak value is now 4. Then the queue values are now 4. Then the dequeued value is 4. Then the queue becomes empty. So this will be it for today's video, guys. I hope you guys learned something useful. And thank you guys for watching. Don't forget to hit the like and subscribe button. And I'll see you in the next DSA episode.